Okay, welcome back to my YouTube channel. I want to explain for you to computer science student at Makerere University. I'm going to take you through soccer prediction using AI. We are going to discuss a lot of things: the Bayes networks, the Bayes theorem, and the native Bayes. So, this is our problem statement: the high and increased risks in playing sports betting, mainly in soccer prediction, and the AI is going to help us analyze the matches, correct scores, and all things we need to do or to take care of while predicting advances in sports betting. So we got our data set. Our data set is called the European League data set. And this is a data set for got it from Cargo. That's the link. I will provide the link in the description below so that it can help us in the future videos. If you're following my videos, you can use it as we're working with our project. And the data in this data set, we have the football players from all leagues and their corresponding data. For example, their form, the way they have been performing, and they perform of the competing clubs since 1992. For this case, we have taken the Premier League since it was called Premier League in 1992. The goals scored and all the points obtained by the individual clubs. That's for the home and away matches since though we have to get the form for the away and form for the home matches. We're also going to use other data sets to train and test our AI model we are planning to implement or we're going to implement in the future videos. Yeah, for the factors that we consider while picking this data set, we consider data quality, user group, single decision, and the quality data assessment. For the data quality, we depend on the rows, columns, all the data we need according to the project we're working on. The user group, we should know the group we are working with. And for a single decision, you have to decide how are you going to use that data set. You as a person, not as a group, because you're the only person who understands who understands the data set. So another thing is data quality assessment, which I've already explained, whereby we are going to use more data sets. So we come to Bayes' theorem. This is also known as the Bayes reasoning, which determines the probability of events of uncertainty knowledge and the probability theory. It also relates conditional probabilities and marginal probabilities of a random event. This Bayes theory allows us to update the probability prediction of an event match by observing new information of the real world. This is the mathematical theory and it's given by the probability of A given B, whereby this will be equal to the probability of B. Remember here B is our evidence, probability of B is our evidence, so the marginal probability, whereby this probability will equal to the probability of A given B times the probability of A over the probability of B. So a continuation of the Bayes theorem, we have the posterior which we need to calculate, or the posterior probability which we need to calculate. We also need to treat the hypothesis where B the evidence. So probability of B given A is the likelihood which we consider that the hypothesis is true. Then we calculate the probability of evidence. Therefore, this is the prior probability of the hypothesis before considering the evidence, which is the marginal probability, which is the probability of B. We go to the naive Bayes. The naive Bayes is a supervised learning algorithm, which is based on the Bayes theorem and is used in solving problems like classification. It is mainly used in the text classification, including high definition training of the dataset. The naive Bayes classification is used for a simple and most effective classification algorithms, which help us in testing and fast machine learning models that can quickly predict the possibilities, and it's a probabilistic classifier which deals on assumptions and conditions since it follows the Bayes theorem. And the Python implementation of this naive Bayes algorithm is data preprocessing step. You have the data preprocessing step, which includes preparing of data, the fitting of the naive Bayes in the training set. It's like embedding the naive Bayes into our what our our model, and testing accuracy and visualization, whereby you have to display the data that's truly analyzed, like showing the percentage of corrections and all stuff. So the other thing is the Bayes brief network. The Bayes network is a probabilistic graphical model which will present a set of variables, their conditional dependencies using graph. The Bayes network is composed as like building models from data as expert, and it consists of two parts: direct acyclic graph and the table of conditional probabilities. The Bayes network graph is made up of the nodes and the arcs, whereby this is the node, A is the node, and this is the arc, which is the direct arrow, which links a node to a node. And this, if you consider this, A is a parent of B, and B is a child of A. Therefore, A will depend on B. Therefore, in this we have dependencies. Unlike in the naive Bayes where we have independencies, but here each node depends on the other node. Yeah, it's like kind of tree, like those who did the structure development. By the way, to know more about this, know more about the Bayesian theory, you should have classes of probability and statistics which explain more and give quality examples about the theory. So we are going to the differences between the naive Bayes and the Bayesian networks. The Bayesian networks show that all the features are conditional independent of each other. That's what I've told you here, that this will the B will depend on A, and C will depend on B. Therefore, this C, the node C is independent of A, but it's dependent of A, it's dependent of D, and because they are its parent nodes. Therefore, that brings us to the joint probability distribution, whereby this explains that each node in the Bayesian network has a conditional probability distribution. It's given by this probability of that given the parent. Remember, this is random what? They are discrete or continuous random variables. So let's continue to the differences. As I've told you, that the features are conditional independent of each other. Therefore, it permits you to use the Bayesian rule of probability. Usually, independence works on assumptions or conditions, but this network does not need assumptions. It all depends on the dependencies within the Bayes network or models. So for those who need the references, I'm going to provide them in the link below. So thank you very much. Hope all good. Find you in the next one. Thank you very much.